Howdy, folks. Let's get cooking right away. We're going to start at the end today. The bottom line. Set up an equation that makes sense. Use algebra solving skills to solve and check your answer for reasonableness. That's kind of everything you ever learned in Math 1. So let's go back, take it on back to the top. We're still in Unit 7. That's correct. All right, today's learning target, solving problems. Problems. Yes, we're problem solvers. With arc length. Sector area. All right, so last time around we learned how to use them. Now we're solving problems with them. Let's see what we got. Take a look. Shall we? We shall. A circle has a radius of 10 centimeters. So it doesn't hurt to draw a picture. Might help. So over here I'm going to draw a little picture of a circle. I'm going to put a radius on there and just give it a 10 centimeters. That way I kind of know what I'm dealing with. Suppose an arc on the circle has a length of pi centimeters. We're going to draw an arc on the circle. We don't exactly know which arc it is, but we just know it has a length of pi. So what's the measure of the central angle that defines that arc? So here's what we're looking for. We're looking for the angle right here that defines that. And so it's an arc, so we know that the formula is this fraction. We don't know the angle, but we do know that the angle out of 360 times the circumference of the circle should give us the length of the arc. This is the setup. All right, so that circumference of that circle is 20 pi. Why? Because it's pi times the diameter is the circumference. We've been working on that. I mean, you can say 2 times 10 times pi, but it's just easier to do pi times diameter. All right, so now we're kind of setting it up. We're saying, okay, we're going to pause in the action for a moment and say, how do we solve that? Okay, let's actually solve that thing. Okay, here we go. There's your equation. You've got that basically, there's your fraction right here. And there's your circumference right there. And we say that arc length is pi. So let's see, what do we do to solve? You might notice that the pi divided by pi kind of cancels off. So if you start there, you're making some headway here. And then you might notice that then that equals 1. And that n over 360 times 20 equals 1. So you might notice that you have to really the easiest way to do this is just to multiply by 360. So you get 360 over here. And then divide by 20. And you will figure out, if you do that on a calculator, you go 360 divided by 20 is 18. So that means that you've got an angle of 18 degrees. All right, if you need to slow that down, review it again, that's it. That's the setup, that's the solve. We're going to do a few practice problems on these just because they're all a little different, but it's read the problem carefully, solve, set up, and then so it kind of goes back to this. Set up the equation that makes sense. Use algebra solving skills and check your answer for reasonableness. So we're going to pause again and go back to the next problem. At least I'm pausing. You pause as well. Okay, let's take a look at Kieran here. 9.2, enough information. What if we don't have enough information? It's possible. Usually that happens when I screw up a test question. Yeah, we won't get into that at the moment. But let's see, the central angle here of this shaded, so reading the question carefully, the central angle of this shaded, so that's 45 degrees. They're telling us that that angle right there is 45 degrees. The sector's area, the whole area is 32 pi. And Kieran says we can find the area of the whole circle, the arc length, the sector, and the circumference. Can we do everything with that? That's the question. Can we solve the whole enchilada with just that? Priya says, wait a minute, we don't have the radius. We always seem to have the radius, and now we don't have it. Well, let's pause in the action. We'll take it to a new page, and then we'll take a look at what's going on here and see if we can solve if Kieran's correct or if Priya is correct. So give it a pause. Give me a moment to switch, and we'll come on right back. Okay, we're back. Now, I did a little writing here in the meantime. You might have just paused the video. But here's what's going on. We've got the sector of a circle, and they gave us the sector area. Okay, in other words, that's given. It's right here. You got to read the question carefully. It's not the area of the whole circle. It's the area of the sector. You can go back and look at the problem. And then it says we know that pi r squared is the area formula, and we know that this angle over 360, and actually, yeah, I've got the angle. It's 45 degrees. So right there, it looks like I can solve this problem. I just have to solve for r. At some point, r equals. The question then is, how do we do that? And you can start solving. It's going to take one step at a time. So I'm going to go one step at a time here. Okay, how you solve this really depends on your take on it. But really, I've got pi over here and pi over there. If I divide pi off, the pi's go goodbye. Pi in the sky gets out of here. And then what I'm going to do is what's left is r squared. That's actually going to stay there. R squared is going to end up being right here by itself. But I've got 45 times 360. So to get rid of that, the easiest thing to do is to multiply both sides by 360 over 45. And the reason why is because they cancel. So over here you're doing 360 divided by 45. So with the calculator right here, you're doing 32 times 360 divided by 45. You get 256. On the left side, you get some cancellation stuff going on here. The 360 cancels, the 45 cancels, and r squared. Oh, that's a quick stop to the end there. Now it's just square root both sides. You got a radius of 16. That's the bottom line. So the solving part. Watch this again if you need some steps on the solving, but it's more about the setup than the solving. So we're going to pause again before we go to another lesson here. And by the way, I'm just pausing so that I can take a breath here. And we're at 6:40. Let's see if we can keep this under 10. Okay, I saved us a little time here by drawing these myself while I pause the video. Just because otherwise this will be 20 minutes here. So let's see. A rectangular piece of paper, that's 4 by 5. These drawings are not to scale, by the way. I need some room to work here on the page. So right away we're thinking that area of that paper is 5 times 4, which is 20. And if we want to go around the outside, we could say the perimeter is 9 times plus 9 is 18. We could do that. We may need that information, but it kind of helps to read the rest of the question first. So take a pause, read the rest of the question, pause the video. Okay, I'm not pausing the video, so hopefully you paused it. All right. It says that Han cuts out a paper sector of the circle with a radius of 5. So he cuts out a little sector of this. Now, that's the sector. So he's cutting out that. Like I said, these are not drawn to scale. So if that's his sector, he calculates the arc length to be 2 pi inches. So they gave us the arc length. That's kind of critical there. They did give us the arc length. All right, so we know that. Whose paper is larger? So here's what we know. We know the area and the perimeter of the rectangle. What we probably, when we say larger, we're really comparing the areas, aren't we? I mean, isn't that what we're truly comparing the area? And like I said, not drawn to scale, so stick with us. So over here, we need to actually see, well, there's the radius. There's the arc length. How did we get the arc length? We don't know the angle either, do we? So let's see. Let's pause here for a moment and take a look. Got to think about this one. See exactly where we go next. Okay, it ain't magic, like I said. I'm trying to save you a little time here. So I'm doing this drawing. You should probably be doing this on your own, but let's check it out. What's going on here? Here's what I did, what I thought about while the video was paused. They gave me the sector length and the radius. So I put that into my formula. There's the sector length, that 2 pi. So I'm connecting the dots here a little bit. There's my 2 pi. That's my sector length. And then it's the angle over 360 times the circumference. That's what that is right there. And I'm using that idea of diameter times pi. So I'm going to let my phone ring over there for a minute and keep going. Let's see, with a little background music. Here we go. That would be solving for the angle. Now you might wonder, hey, how did you solve the angle? Well, look back at the previous problem. When we solved the angle, we actually, on this one, the pi's cancel out. We do 2 times 360, so we bring the 360 over here. And then we divide by 10 because we want to bring that 10 down below. And you get 72. So what you find out, you solve the angle. And then all of a sudden you solve the angle. and you get 72, and then you say, okay, I got the angle, woohoo! I don't have the area. So then you got to go back up here, and you got to take that angle, and you got to pop it right in there to the area formula. And once again, we're using that area formula, the angle over 360 times the area of the circle overall. And we do know the area of the circle, it's pi r squared. So that's this right here, that's r squared times pi. That's where the 25 comes from. And then we just kind of crank it out. And let's see, if we do grab a calculator here and crank it out, we do 72 divided by 360. That's the fraction of the circle. It's actually 2/10 of the circle. So we could do that and then say, okay, great, 2/10 of the circle times 25. And that's 5, so it's like 5 pi. But the problem is that here's the problem. The area of the rectangle we know is 20. I mean, it's right there on the page. We don't have to guess at that. So we do need to finish this thing off and actually finish it. 25 times pi. That's the whole thing mulls out. Let's see, what do we got here? We get 15.7. And so that's the area of the sector. So when they ask you whose paper is larger, that's a strange question, but if we had to determine that, that's how we would do it. All right, so rewind that one, check that one out again. We got a couple more to go here, and we're going to pause in the action again and get everything set up for you for the next one to save you some time. All right, in the interest of time, a circle with a radius of 10, that's a radius of 10, has an arc on it that has a length, and that's arc length, of 8 centimeters. So it looks like we're going to be needing the arc length formula. What is the measure of the central angle? Well, if we use the formula, let's see. I take the angle. I need the angle. I don't know that angle, but if I do that over 360, and I multiply that by the circumference times pi, pi times the diameter, that's going to be 20 pi. And they tell me that that's equal to 8 pi. That's the setup. So pause it if you need to and set it up. I'm going to pause as well to give you some time to think here for a moment. You think, I'll think, and then we'll come back. When you're ready, come back and see if you could get that on scratch paper. See if you can solve this thing before I do. Okay, if you got a chance to think about it, you probably thought that there was something going on with the pi. Once again, divide both sides by pi. And I mean, I know we don't show it all the time, but if we do show it, we're dividing by pi. That's why the pi's cancel. So just so you know, they're not just magic. They're not just going away. And then we come back in and we say, okay, we're coming in for the kill here. We got 8 equals n over 360 times, I mean, what you really have here is n over 360 times 20 equals 8. So you want to solve that. And the easiest way really is just to take the 8, multiply by 360, and divide by 20. And there's a reason for that. That's divided by 360, so you want to multiply it. And that's times 20, so you want to divide by it. And when you're all said and done, you get 144 degrees. All right, so not that tough when you finally take a good look at it. But once again, your drawing doesn't have to be perfect in the beginning. Don't worry about your drawing. Just get it on paper so you can see kind of what's connected to what, not necessarily that's drawn perfectly. All right, we got, I think, one more here. Is that right? Oh, yep, there's the bottom line again. Don't forget, set up the equation that makes sense. You might need arc length. You might need sector area, but use the one that works with what you've got. Use your algebra solving skills. That's probably the toughest part of this, is the algebra. And then check to make sure your answer does make sense. If you get an angle of 540 degrees, obviously that ain't going to cut it. So let's come back to the last one. Circle. Here it is. A circle. Radius. 6 units. There it is. For each arc length, find the area of the sector. Oh, so we're just calculating sector area here. Okay, so I'm going to pause this the moment action. We're finding the sector area. So that is the angle over 360 times the area. And in this case, that's pi times the radius squared, so that's 36 pi. All right, so that's what we're doing. We're just running this through. And there's the arc length. So I've got the arc length. I've got to go back and find. What do I have to go back and find? Let me pause here. Okay. Reread the problem carefully. Sometimes when you get stuck, you pause and you reread the question carefully and say, okay, I'm trying to find the area. There it is, but I don't know the angle. So that's the problem there, is I don't know the angle. So if I don't know the angle, I've got to do a few things here to play around with that. And that means, number one, that I've got to come over here to this. I've got this is this arc length. So I've got the arc length. It's right there. So I've got to use this formula. There's the arc length of 4 pi. And here's the expression that defines the arc length, and I've got to solve that. So you do have to solve for n here. And you've got to, once again, the pi's cancel out because they divide off. And it's really just 4 times 360. Bring that 360 over, and then divide by 12 underneath. So you're doing 4 times 360, and you're dividing it all by 12, and you get a 120-degree angle. Well, you come back over here and you say, okay, well, great, that's the 120-degree angle there. Use that. 120 over 360 is 1/3. So really all you're doing is 1/3 times 36 times pi. And 1/3 of 36 is 12. So really what you're saying is that if the arc length is 4 pi there, let me get some. If the arc length is 4 pi, I'm solving it back to get the angle, and then I'm using that angle to then continue on and get an expression for the area. So arc length of 4 pi gives me a area of 12 pi. And now with that, I mean, that's enough for you guys to go on. I'm at 16 minutes here. So this lesson's getting a little old. I think I might pause it since you're watching this without me at the moment, maybe. And do one more just for the sake of argument here. So hang tight. I'm going to erase this and start a new one here. We'll do 2 of these just because these ones are a little tough. Okay, let's do the same setup as we did on the last problem. This is the section here. This is the expression for the arc length. So it's that fraction, we don't know the angle again, out of 360, and that is the circumference, 12 pi. All right, pi times the diameter. And then they tell us that if it equals 5 pi over here, we can use that. So let's do the solving piece. And once again, this is really just a calculator portion. It's not much more than that. So what we do is we get a different color, first of all. And we say, okay, that's going to be over here, 5 pi. Well, the pi's cancel out. You got 5 times 360 divided by 12. And you end up with an angle there of, what is it? Looks like 150. And then you take that 150 and you bring it on over and you drop it in here to the area formula, and then you run it. 150 divided by 360. Oops, your calculator has to work to do that. 150 divided by 360. And you get a fraction and a decimal, and you multiply that by 36. And you get 15. So it's 15 pi. All right, we can leave our answer in terms of pi. All right, so a little bit of calculator work and a little setup. All right, I'll let you do the last 2 on your own. Check it. The answer solution should be posted in the locker and everywhere else along the way. No problems. Let's call it there.